Okay, so I need to talk to you guys about something that has people freaking out on social media right now, especially in the AI community. Apple just released this research paper that basically says all of these fancy thinking AI models that everyone's been going crazy about, well, they might not actually be thinking at all. And the timing of this is absolutely wild because it dropped just days before Apple's big developer conference where everyone expected them to show off their AI stuff. Part 1, the bombshell nobody saw coming. All right, so here's what happened. On June the 7th, 2025, literally just 2 days ago, Apple's machine learning team published its research paper with probably the most provocative title I've ever seen in AI research: The Illusion of Thinking, understanding the strengths and limitations of reasoning models via the lens of problem complexity. And when I first saw the title, I was like, wait, did Apple just call out the entire AI industry? This new story genuinely has people freaking out because basically, Apple took all these super advanced AI models that are supposed to be the future of AI. We are talking about frontier models, guys. OpenAI's O3, Anthropic's Claude, DeepSeek R1, and even Google's recent thinking models, and they put them through a series of tests that completely exposed their limitations. Now, I was also surprised to find out that Apple has been doing serious AI research behind the scenes. Like, most people think of Apple as the company that just makes iPhones and MacBooks, but they actually have this entire machine learning research division that's been quietly working on understanding how these AI systems actually work. Now, remember how I spoke about the timing being crazy? It's honestly laughable. Apple's worldwide developer conference is happening literally today, June 9th. And everyone is expecting Apple to finally show off some impressive AI features to catch up with Google and OpenAI. But instead of hyping up AI, they basically just published a paper saying that the emperor has no clothes. Now, what makes this even more interesting is that Apple has been struggling big time with their AI efforts. Their Apple Intelligence features have been just simply delayed, and Siri still isn't that great. In fact, I've even recently made a video on Perplexity Voice Assistant, and it's miles ahead of what Siri can do. And Apple have even been getting roasted for being behind in the AI race. So when Apple comes out and they publish a paper essentially saying that, look everyone, hey, maybe this whole reasoning AI thing isn't as amazing as everyone thinks, you have to wonder, are they being genuinely scientific, or are they just trying to move the goalposts because they're losing the game? I came across this article that mentioned how Apple's former design chief, Jony Ive, actually left to work with OpenAI, which is basically a slap in the face for Apple, and I made a video on that recently. The device is pretty crazy. It's pretty weird. It's like your star employee leaving to join your competitor, and then immediately your company starts publishing papers about how the competitor's technology doesn't really work. Seems a little bit fishy. Now, let's take a look at what Apple actually discovered, and I gotta be honest, despite the criticisms, it's pretty mind-blowing. So let me break down exactly what they found, because this is where it gets super interesting. Instead of using typical AI benchmarks that everyone uses, you know, those math problems and coding tests that these models usually ace, Apple created their own testing environment using puzzle games. They specifically used variations of the Tower of Hanoi puzzle, which is this classic problem where you have to move disks from one peg to another following specific rules. What's brilliant about this approach is that they could precisely control how complex the problems were. They started with super simple puzzles with just one disk and scaled all the way up to really complex ones with 20 disks. And here's where it gets wild. Apple found that there are basically 3 different performance zones when you test these AI models. So first, there's the low complexity zone. Now this completely blew my mind. The regular AI models actually perform better than the fancy reasoning models on simple problems. It's like having a race car that's actually slower than a regular car in city traffic because it's over-engineered for the task. Then there's the medium complexity zone, which is where reasoning models actually shine. This is where you see those thinking models like Claude and O3 really outperform the standard models. So there's a sweet spot where all that extra thinking actually helps. But here's the kicker. In the high complexity zone, both types of models just completely collapse. Their accuracy basically drops to 0. And this isn't because they ran out of time or computing power. Apple gave them plenty of both. The models just gave up. Now, what's even more fascinating is this weird behavior Apple discovered. As problems got harder, you'd expect the reasoning models to think longer and harder, right? But that's not what happened. Initially, yes, they would spend more effort reasoning as problems got more complex, But then at a certain point, they actually started putting in less effort. It's like they could sense that a problem was too hard and just decided to phone it in rather than really trying to solve it. I was also surprised to find out that Apple tried something really clever. They actually gave these models the exact algorithms needed to solve the puzzles, like literally handed them the step-by-step solution method, and the models still failed on complex problems. This suggests that these models aren't actually doing logical reasoning the way that humans do. They're more like really sophisticated pattern matching machines. The researchers found that when AI models encounter a problem they've seen variations of before, they can handle it pretty well because they're essentially retrieving and adapting memorized solution templates. But when they face truly novel, complex problems, their supposed reasoning abilities just evaporate almost instantly. Part 3, the great AI reasoning debate and why everyone on Twitter is arguing. Now here's where things get really spicy. Because the AI community is absolutely divided on what this research actually means, some people are treating this like Apple just proved that AI reasoning is fake, while others are saying Apple completely missed the point. The whole controversy genuinely has people picking sides like it's a sports game. On one side, you have people saying that this proves all the hype around reasoning models is just marketing nonsense. I came across this comment from someone who said that this paper shows that these models are essentially just probabilistic tape recorders rather than actual thinking machines. But then there's this whole other camp that is basically pushing hard back against Apple's conclusions. Let me show you guys a Twitter thread where there are a lot of researchers agreeing with this individual. So this Twitter account called Scaling01 tweeted several different things regarding this research paper that I think you ought to know. And so what I will do is give you the cliff notes of this Twitter thread. So I'll basically explain to you what this Twitter thread says in the cliff notes version. When we look at Tower of Hanoi, every move takes around 10 tokens, which is basically kind of like words. So for 8,191 moves, that's 81,910 tokens. And most of these AI models have a limit on how much they can output. Now, DeepSeek R1 can output 64,000 tokens. Claude 3.7 Sonnet and O3 Mini can output 100,000 tokens to 128,000 tokens. So, if the total number of moves goes past that token limit, the model physically can't output the whole answer. It's like trying to write a book in a Twitter post. So what's the point? Well, the Apple paper claimed that these AI models collapse in accuracy at higher complexity puzzles, like the Tower of Hanoi with more disks, implying that it is a reasoning failure. But the tweet is saying that, bro, it's not that models get dumb, it's that they can't even finish writing the answer. That's why they fail. It's obvious. So there are some key observations from the tweet, which basically says you need 2 to the power of n-1 moves to solve the puzzle, basically stating that, look, this thing grows fast and each move takes around 10 tokens. So once n gets too big, like, 13 disks, the model just runs out of room. Even if the model could think perfectly, it's like trying to write a 200-page essay in a 10-page notebook. The tweet also roasts the models for pretending to think, where it says, I won't list all 3,200 moves, I'll just explain the idea, which is basically the translation saying, look, I just ran out of space. And it kind of points out that even when there's room, some models just give up and explain the method, they don't even try. So essentially, the Apple paper is saying that models fail at hard puzzles because they can't reason, but the Twitter thread says that, nah, they fail because they hit their word limit. It's basically like blaming a singer for not finishing the song when the mic got cut off halfway. Now, there's also another part of this Twitter thread that I think is pretty interesting. And once again, I'm going to give you guys the simple version. So why can LLMs handle the Tower of Hanoi but fail on easier looking puzzles? Well, in the Apple paper, they define a puzzle's difficulty by how long the shortest solution is. And the Tower of Hanoi, remember, needs 2 to the power of n-1 moves, which is exponential. Whereas checker jumping is quadratic, and river crossing and blocks world is linear-ish. So they go, Tower of Hanoi is going to be the hardest because it takes the most moves. But that's probably not the smartest way to define difficulty. And here's why this Twitter thread says that logic might be flawed. Just because something takes a long time, it doesn't mean that it's harder to figure out. For example, Tower of Hanoi is just one clean recursive rule. There are no choices, no searching, there's no guessing. You can mindlessly follow the same rule and win. But with river crossing, on the other hand, it needs careful planning. There are multiple valid looking options, but most will lead to failure unless you think ahead. So while the Hanoi solution is long, it's actually very easy. While river crossing has short solutions, they're actually really hard to find. So this person actually asked O3 and Gemini 2.5 Pro to come up with better measures of puzzle difficulty. And will you guess what? The models actually ranked puzzle difficulty like this. They put river crossing first, blocks world second, checker jumping third, and Tower of Hanoi last, which matches what the paper's own performance charts show. Hanoi gets solved far into high move counts, whilst river crossing fails early. So what's the burn here? Well, Apple said that models struggle with puzzles that have lower compositional depth while succeeding on puzzles with higher compositional depth. That's weird and puzzling. But this Twitter thread basically says that it's not puzzling, you just measured the difficulty wrong. You use the solution length as a proxy for how hard it is to think, and that's not how reasoning works. The TLDR is basically, Apple says that this task they evaluated the models on are harder because it takes more moves, so the models failing on a simpler puzzle is weird. But the tweeter says, nope, Hanoi is just long, not hard. River crossing is actually hard, and your metric is busted. So maybe the puzzling behavior of reasoning models isn't mysterious, it's just a bad case of assumptions. Now, it wasn't just this person in a Twitter thread that gave us this explanation. There was also an analysis from a guy named Richard Aragon who made a YouTube video about how people are misinterpreting the paper. He argues that the paper doesn't disprove reasoning in AI at all. It just shows the current limitations and actually provides evidence that reasoning does work within certain bounds. Then there's this whole other angle about Apple's motivations. I came across multiple discussions where people are basically saying, of course Apple is downplaying reasoning models. They don't even have any good ones. It's like when you can't afford the fancy restaurant, so you tell everyone expensive food isn't actually better. Now, some critics are pointing out that Apple's choices of puzzles might not be the best test for reasoning ability anyways. Like, just because a model can solve a 20-disc Tower of Hanoi puzzle doesn't mean it can't reason about real-world problems that actually matter to humans. What's really interesting is how this connects to broader questions about what we even mean by reasoning and thinking. Some researchers argue that humans also have limits. We can't solve infinitely complex problems either, and we also rely on pattern recognition and memorized strategies. So maybe these AI models are more human-like than we thought, perhaps in ways that we just didn't expect. Now, the Twitter thread and the other guy on YouTube weren't the only people who were making claims about this Apple paper. I'm pretty sure it wouldn't be an AI critique video without mentioning Gary Marcus. So here's where things get really spicy. Gary Marcus has a title of an article called "Knockout Blow for LLMs." This dropped the same day as Apple's paper. And let me tell you, this man is not holding back. I mean, he never really has. He's kind of doing a victory lap while simultaneously dropping truth bombs that has the AI community split right down the middle. First off, Gary Marcus reveals something wild. Apple's paper actually name checks his decades-old arguments about neural networks failing outside of their training data. He's been screaming into the void about this since 1998 when he published a paper skewering early neural networks for failing simple math problems. And fast forward to 2025, and here's Apple using his playbook to take down billion-dollar AI models. Marcus writes, "This was the crux of my 1998 paper, and central to my first science paper in 1999, showing infants could out-reason neural nets." Talk about a full circle moment. But here's what really caught my attention. Marcus points out that Apple's Tower of Hanoi findings aren't just embarrassing for AI companies, they're existentially terrifying for the AGI crowd. He notes that Herb Simon, one of the AI godfathers, solved Hanoi with 1950s level tech, whilst modern LLMs choke on 8 disks despite having access to all of human knowledge. And his killer line is that if you can't use a billion-dollar AI system to solve a problem that first semester CS students handle, then your chances of reaching AGI seem truly remote. Now, I was surprised to find out that Gary Marcus actually agrees with one of the criticisms of Apple's paper, which is, like I mentioned before, the fact that humans also struggle with complex Hanoi problems. But he also fires back with this singer. we invented computers precisely to handle what humans can't. Why would we want an AGI that shares our flaws? He argues that true intelligence should combine human creativity with machine precision and not just mimic our limitations. He's a real advocate for neurosymbolic AI. Now, what makes Marcus's take different is how he connects Apple's research to the bigger picture. He drags up his 2022 essay, "Deep Learning is Hitting a Wall," and shouts "I told you so" to anyone who claimed scaling would solve everything. His Substack post actually went viral for this brutal assessment. LLMs are like race cars stuck in first gear. Impressive acceleration, but zero ability to climb actual hills.
Although I think there's been some improvement, there has not been the quantum leap that people are expecting. We have not moved past hallucinations. We have not moved past stupid reasoning errors. If you go back to my 2022 paper, Deep Learning is Hitting a Wall, I didn't say there'd be no progress at all. What I said is we're going to have problems with hallucinations. We're going to have problems with reasoning, with planning, until we have a different architecture in some sense. And I think that that's still true. We're still stuck on the same kinds of things. So if you have deep research write you a paper, it's going to make up references.
Okay.
It's probably going to make up numbers. Like, did you actually go back and check?
But here's the actual plot twist. Gary Marcus isn't just dunking on AI. He reveals he's been DMing with Apple's researchers, including the co-author Iman Mirzadeh, who told him, "We gave models the solution algorithm and they still failed. Their process isn't logical." This behind the scenes detail adds serious weight to Apple's claims. Now, the comment section under Marcus's post is kind of like a war zone. You've got venture capitalists arguing with CS professors about whether this is the end of AI Winter 2.0. Now, like I said before, Gary Marcus also ties this into Apple's WWDC timing. He actually suggests that Tim Cook is playing 4D chess, releasing this paper to reset the expectations before announcing practical AI features. While others are chasing AGI, Apple might settle for artificial useful intelligence, given Apple's failed AI launches. And I'm looking at you, Siri. This could potentially be their chance for a redemption arc. And why did I even bring this into the video surrounding Apple's AI paper? Well, of course, Gary Marcus has been a heavy critique of LLMs for quite some time right now, and he represents the growing AI realist movement, demanding we stop overhyping systems that can write sonnets but fail basic logic.
And so forth. So we're still, I think, a ways from having the practical AI that we're now dreaming of. Like last year was amazing. It brought AI to the public. People realized, hey, this might really help me. But at the same time, I think it was premature. And that right now, the tools that we have are limited in what they can actually do. And we're kind of like fantasizing about some future world. But the tools we don't have, or the tools we have right now, are limited.
His take resonates because it's not just criticism. He's advocating for neurosymbolic hybrids combining LLMs with old school AI.
Some people take me as saying that AI is impossible. And that's not me, right? I actually love AI. I want it to work. I just want us to take a different approach, right? I want us to take a neurosymbolic approach where we have some classical elements of classical AI, like explicit knowledge, formal reasoning, and so forth, that people like Hinton have kind of thumbed their nose at, but that, say, Demis Hassabis is used very effectively in AlphaFold. So we get into that if you want. If we get to AI, the question about whether I'm right or not depends on how we get there. So I've made some pretty particular guesses about it, and I have guessed that pure LLM will not get us there. Pure large language model.
As one comment actually put it, Marcus isn't trying to kill AI, he's trying to grow it up. Now, the big question here is whether Apple's AI paper and Marcus's amplification will force AI labs to pivot, or if they'll double down on the scaling gamble. Either way, the next chapter in this showdown is going to be very interesting. So, well, where does this leave us? Well, firstly, the timing of this research tells us a lot about Apple's strategy going into their developer conference. While everyone is racing to build bigger and more complex systems, Apple is basically saying, hold up, maybe we are going down the wrong path here. I think what's really happening is that Apple's trying to position themselves differently in the AI race. Instead of trying to build the most impressive reasoning model, they're focusing on, practical AI that actually works for real users. Although I haven't seen any yet, I guess that's the route they're trying to go down. Because when we think about Apple's entire brand, it really is around products that just work, not products that are technically impressive but somewhat unreliable. That really won't cut it for Apple. And this research also reveals something important about the current state of AI development, where everyone's making grand claims about AI capabilities that aren't quite there yet. This Apple paper is like a reality check that's forcing the industry to kind of be a little bit more honest about its current limitations. Here's what I find most interesting. This research might actually accelerate AI development rather than slow it down. Now that we have a clearer picture of where current models fail, researchers can focus on solving those specific problems. It's kind of like having a detailed map of where the road ends, which makes it easier to figure out how to build the next section. For Apple specifically, this research gives them cover for taking a different approach to AI. Instead of trying to compete on raw reasoning capability, they can focus on making AI that's more reliable, efficient, and practical for everyday tasks. This actually plays to Apple's strengths. They've always been better at making technology user-friendly rather than technically impressive. And I was surprised to find out that this research might influence how other companies develop AI too. Think about it for a second. If Apple is right that current reasoning models hit fundamental scaling limits, then companies like OpenAI and Google might need to completely rethink their approach. We already know that some of the most talented AI researchers are taking this approach. Remember when I made that video about how LeCun said he's done with LLMs?
I'm not so interested in LLMs anymore. You know, they're kind of the last thing. They are in the hands of, industry product people, kind of, improving at the margin, trying to get, more data, more compute, generating synthetic data. I think there are more interesting questions in four things. How do you get machines to understand the physical world? And Jensen talked about this this morning in his keynote. How do you get them to have persistent memory, which not too many people talk about? And then the last two are, how do you get them to reason and plan? And there is some effort, of course, to get LLMs to reason. But in my opinion, it's a very kind of simplistic way of viewing reasoning. I think there are probably kind of more better way of doing this. So I'm excited about things that a lot of people in this community, in the tech community, might get excited about 5 years from now. But right now doesn't look so exciting because it's some obscure academic paper.
And he actually advises that, if you're researching the future of AI, just don't work on LLMs, work on something else.
Young students who are interested in AI research for the next generation AI systems, and tell them, do not work on LLM. There's no point working on LLM. This is in the hands of product divisions in large companies. There's nothing you can bring to that table. You should work on the next generation AI system that lifts the limitation of LLMs, which all of us have some idea where they are.
And I mean, the broader implications here are pretty significant. If reasoning models do really have these fundamental limitations, then all the predictions about AGI being just around the corner might need to be seriously reconsidered. We might be looking at a much longer timeline for truly intelligent AI than the hype cycle suggests. And to be honest with you guys, this AI field moves so fast that by the time this video goes live, there probably will be several responses to Apple's research from other companies. But what's clear is that this paper has started a conversation that needed to happen about the real capabilities and limitations of current AI systems. Now, I need you guys to understand that this is not the first time that Apple has, challenged the AI reasoning hype. Apple literally has a pattern of doing this. In 2024 of October, I even made a video on a paper that Apple made called GSM Symbolic, Understanding the Limitations of Mathematical Reasoning in Large Language Models. And I gotta be honest, it wasn't like this research was set out to destroy LLMs, it actually pointed out some fundamental flaws. So this research basically demonstrated that even the most advanced AI models rely on sophisticated pattern matching rather than genuine logical reasoning, with performance drops of up to 65% when faced with subtle variations. The paper arrives as a part of a broader research agenda that of course now includes the Illusion of Thinking paper, which is the one I'm talking about now, which shows that this establishes a clear pattern of the company serving as a scientific counterweight to AI reasoning hype, precisely at the moment when competitors are near basically promoting AGI capabilities. So if you're wondering how they did this, they basically created an ingenious testing framework that exposed fundamental weaknesses in AI reasoning claims. They developed GSM Symbolic, which was a reasoning benchmark that generates variations of grade school math problems by converting fixed questions into parametric templates with variable placeholders for names, numbers, and context. The methodology involved creating 100 original templates from GSM 8K test questions, generating 50 different instances per template, resulting in 5,000 examples. And most critically, they tested models' responses to irrelevant information by adding seemingly relevant but mathematically unnecessary clauses to problems. And the results were devastating. When Apple added a single irrelevant sentence to math problems, such as mentioning that, Sarah may have bought 3 pencils in a problem that didn't require that level of information, performance collapsed across all state-of-the-art models. GPT-4o dropped from 95% to 63.1% accuracy, while OpenAI's reasoning-focused O1 preview fell from 96% to 77.4%, and smaller models like Phi 3 Mini crashed from 85% to just 18% accuracy. And even more telling, the researchers found that simply changing numerical values in problems and keeping everything else identical caused performance variations of up to 15%, suggesting that models were memorizing specific number patterns rather than learning mathematical principles. Now, once again, like the paper that we have now, this paper sparked intense debate across the AI research community. Gary Marcus was calling this pretty devastating to LLMs, but of course, some people were pushing back as they are with this paper. And some people argued that, well, humans would probably also suffer the same fate. I mean, wouldn't you struggle with a deliberately misleading question or deliberately distracting information? I know I sure would. Now, this connects directly to Apple's 2025 Illusion of Thinking paper, which of course examined large reasoning models and of course their complete accuracy collapse. And so when we look at the previous papers, which is GSM Symbolic and Illusion of Thinking, I think it's quite clear that Apple's position is that current AI reasoning is exactly what the title suggests. An illusion created by sophisticated pattern matching that breaks down under systematic scrutiny. And so when we take a look at this, we can see that Apple's GSM Symbolic paper and the recent one represents Apple's foray into AI skepticism. And it's quite clear that Apple probably will continue with a pattern of challenging reasoning hype with rigorous research and positions them as an important to counterbalance AI industry marketing narratives. Whether or not that's because they are behind the 8 ball when it comes to AI, I will have to leave that up to you. But honestly, I think the most important takeaway is that we need to be more realistic about what AI can and can't do. These models are incredibly powerful tools, but they're not magic, and they're definitely not human-level reasoners yet. Understanding their limitations isn't actually pessimistic, it's practical and helps us use them more effectively. And let's just say that you don't believe in LLMs and you think something else is going to come. Well, you might actually want to listen to what LeCun has to say, because he believes something else is on the horizon.
So currently, AI systems are in many ways very stupid. We are fooled into thinking they are smart because they can manipulate language very well. But they don't understand the physical world. They don't really have any persistent memory of the type that we have. They can't really reason and they can't plan. And those are essential characteristics of intelligent behavior. So one of the things that my colleagues and I have been working on at FAIR and at NYU actually is designing a new type of AI system, still based on deep learning, that would be capable of understanding the physical world, have persistent memory, be able to reason and plan. And in my opinion, once we succeed in building those systems around this blueprint, those systems will have emotions. So they'll have emotions like maybe fear or excitement or elation, because those are anticipations of outcome. Those systems will basically work by having a goal that we set them to fulfill. We'll give them goals to accomplish. And then they will try to figure out what kind of actions can I take so that I fulfill that goal. If they can predict in advance that this goal will be fulfilled, it will kind of make them happy, if you want. Okay, or if they predict that they can't, it will, not make them happy. So to some extent, they will have emotions because they'll be able to anticipate the outcome of a sequence of actions they might take.